Something old is moving, and experts are raising the alarm. Satellite data has shown an unexpected quick rise in the core of the Appalachian Mountains. A location formerly thought to be geologically inactive is now actually rising. The Appalachian Mountains, which were formed hundreds of millions of years ago and were thought to be in a state of silent decline, have begun to change. Geologists have issued a rare red alert as sensors continue to detect vertical ground motion, with no obvious end in sight. What is causing this? And why now? The answers might revolutionize our understanding of North America's most mysterious mountain range. It began with a normal satellite pass. High-resolution synthetic aperture radar, SAR, with interferometric capability, detected unanticipated ground movement in central Appalachia. What should have been a steady baseline scan revealed vertical displacement, which was first minor but progressively compounded. Within a few days, the crust in sections of West Virginia, and eastern Kentucky had risen by up to 12 centimeters. That's not only exceptional, but unprecedented. The data was not a fluke. Each subsequent satellite pass verified the pattern, with precision interferometry, catching millimeter-scale alterations across a large geological footprint. NASA and USGS researchers worked quickly to cross-reference the satellite picture with seismic, GPS, and geological data. What they discovered was sufficient to elicit one of geoscience's most unusual responses, a red alert. This notice is not given lightly. It denotes not just documented geological movement, but also ambiguity regarding its cause and prospective effects. This is not a one-off change induced by groundwater extraction or mining. It is regional, deep-rooted, and escalating. For a mountain range that has been deemed tectonically quiescent for hundreds of millions of years, this type of activity is a siren cry. Something is awoken beneath the Appalachians, and the scientific community is keeping a careful eye on it. The Appalachian Mountains are among the most ancient on Earth. During the Paleozoic era, they were towering giants that rivaled the current Himalayas. But it was over 480 million years ago. Erosion has now worn them down into rounded hills and ridges, resulting in the soft contours seen throughout the eastern United States. For years, scientists assumed this range had fallen into tectonic dormancy, a quiet geological zone with no active faults, magma chambers, or elevation. Appalachian geology was founded on stillness. Unlike the West Coast dynamic mountain systems, the Appalachians were seen as stable crust. There is no substantial volcanic activity. There are no subduction zones, no big earthquakes. The only motion seen were glacial rebound effects, which were tiny and slow-moving leftovers of the previous ice age. That's why the geological community has been taken aback by this unexpected elevation. It challenges Appalachia's long-held identity. It poses difficult questions. Did we misjudge the forces that lie underneath these hills? Are there old tectonic scars resurfacing after ages of silence? Could this range, which was assumed to be in a condition of silent decline, nonetheless be capable of significant geodynamic shifts? Until today, the answer would have been a definitive no. Today, even that confidence is being questioned. In geologic jargon, 12 centimeters of uplift in less a week is considered a seismic sprint. Mountains seldom shift so quickly, unless something huge is pressing from below. Typically, crustal elevation varies over decades, centuries, or even millennia. However, what satellite data revealed in the Appalachian area defied all predictions. This uplift was not limited to a single fault or valley. It expanded throughout a multi-state zone in a distinct, accelerating pattern. Consider this. Even a crustal increase of 1-2 millimeters each year is generally significant. However, in less than 7 days, some zones increased by more than 100 times that pace. The speed and size are indicative of deep, tremendous forces, most likely originating in the mantle or lower crust. The ramifications are startling. Such movement stresses the fragile top crust, potentially reactivating latent fault lines. It disrupts the gravitational equilibrium in the region, modifies water table movement, and strains infrastructure established on the premise of geological stability. It is not just uplift, it's a shift in stress fields, a geological wake-up call. Geologists compare this type of occurrence to witnessing a glacier race or a sleeping volcano awaken. Whatever is rising beneath the Appalachians isn't done yet. Scientists are delving deep into the earth as the ground rises and there is no obvious cause. Several competing explanations have developed to explain the unexpected increase, but all question long-held beliefs. One leading idea includes mantle upwelling, which is a plume of hot material rising from deep below the Earth and pushing up the crust, like dough from below. This type of behavior has previously been observed in active volcanic zones such as Yellowstone and the East African Rift, but never in the peaceful Appalachians. If true, it might indicate a tectonic reawakening. Another possibility is delamination, which occurs when a piece of the lower crust or lithospheric mantle tears away and sinks, allowing the lighter top crust to buoyantly bounce upward. This has been observed in the Andes and Sierra Nevada, but has not been proven in the eastern United States. Others believe supercritical fluids, compressed high-temperature combinations of water and gases, are forcing their way through crustal vulnerabilities, raising the ground as they go. These fluids may also soften rock, making it more prone to subsequent movement. Every hypothesis has validity. None of these are comfortable, because whether it's heat, pressure, or fluid dynamics, the message is the same. The deep earth underneath Appalachia is altering rapidly. The Appalachian Mountains aren't usually connected with earthquakes. Their fault systems are ancient, decrepit, and were previously thought to be dormant. However, crustal uplift alters the equation completely. When land rises quickly, stress is redistributed, and whenever there is tension, there is a risk of slide. Seismographs began to detect something worrisome in the days following the satellite detection: microseismic activity. These are small vibrations that are frequently undetectable to people, yet are essential for scientific predictions. A sudden grouping of these microquakes shows that old fault lines are reacting to fresh pressures underneath. The risk is not purely theoretical. Many of these faults have not been completely mapped. Their bounds, angles, and stress thresholds are poorly known since no one anticipated them to be significant again. Rapid uplift might cause fault reactivation in areas without earthquake preparation equipment. Cities like Charleston, Roanoke, and Knoxville are uncomfortably near to these zones. Schools, roadways, pipelines, and electricity grids are all intended for a geologically stable region. That presumption is eroding. Even a modest earthquake of magnitude 5 or the 6th of May caused substantial damage in this region. The red alert is about more than simply uplift. It is about the increasing likelihood that something deeper and more deadly is developing beneath our feet. A complex of old fault zones lurks under the Appalachians' gentle slopes, long assumed to have been petrified by time. These fault systems, which are relics of the tectonic collisions that generated the supercontinent Pangaea, have been geologically silent for hundreds of millions of years. However, with the abrupt ascent, small symptoms of reactivation are emerging. Tomographic scans and magnetotelluric imaging have revealed linear stress fractures deep into the crust, some of which coincide with long-forgotten suture zones. GPS arrays detect lateral strain over the uplift sides, indicating more than simply vertical displacement. The patchwork of hidden faults complicates forecasts. If even one slips under the heightened strain, it may set off a chain reaction. This isn't the reawakening of a single fault. It's the rumbling of a long-forgotten tectonic history, moving in pieces. And in this geological puzzle, one error might repaint the seismic landscape of the eastern United States. The Appalachian uplift is not functioning alone. It is supported by a chorus of tiny but crucial signals. Magnetometers installed on airplanes found small variations in local magnetic fields across the impacted area. While these anomalies do not interfere with navigation, they indicate that magnetic materials in the crust are being shifted, most likely by deep geodynamic activity. Meanwhile, microquakes continue to occur throughout the region, with many too weak to be felt but strong enough to record on regional seismographs. These are the Earth's murmurs before a potential outburst. They suggest tension, movement, and possibly the early stages of fault reactivation. Geothermal studies have contributed a third piece to this growing jigsaw. Slight increases in deep borehole temperatures point to growing mantle heat. If a mantle plume is involved, this is more than simply a surface blip. It is a full-fledged tectonic revival. The confluence of magnetic, seismic, and thermal data is establishing a case that something significant is occurring underneath Appalachia. Uplift not only reshapes geographies, but also people's lives. Cities like Charleston, Knoxville, and Roanoke are located inside or near the active uplift zone. These metropolitan areas were built on secure ground, but that trust is being called into doubt. Roads, bridges, pipelines, and buildings were not built to stretch with the moving crust. Subtle terrain elevations can stress foundations, damage roadways, and jeopardize electricity lines and gas pipelines. Worse, water infrastructure may be at jeopardy. Rising topography may reroute rivers, stress dams, and modify aquifer flows, resulting in floods and shortages in the same area. Reservoirs like the Tennessee River system may experience flow anomalies as terrain moves further. Emergency management teams are increasingly simulating not only earthquakes, but also cascading infrastructure failures. The true hazard is not just geological, but also logistical. A silent rise in elevation may discreetly disrupt the systems that millions rely on every day, and there is no way to turn off what is going on underneath. In an unexpected twist, scientists are re-examining indigenous oral traditions that characterize the Appalachians as living mountains or sleeping giants. For years, these stories were regarded as figurative, spiritual folklore rather than geological records. But with heightened tectonic activity, those stories are garnering new attention. Anthropologists and geoscientists are collaborating to investigate trends in historical behavior, animal migrations, spring disturbances, and unexpected weather, all of which were previously regarded as anecdotes. Could they be long-term reactions to tectonic activity? Similarly, inexplicable previous abnormalities, such as unexpected radon surges, mild earthquakes from mapped faults, and unusual river behavior, are being investigated. What was originally thought to be chance might potentially represent early signs in a long-cycle tectonic pattern. By combining traditional knowledge with current data, researchers expect to gain a more full picture of the region's behavior across time. Sometimes the past whispers warnings that science can't yet detect. Now those murmurs are being heard. Every geologist wonders if this is a one-time occurrence or the beginning of something far larger. If present patterns continue, with rising crust, reactivated faults, and heat surges, we may be witnessing the birth of a new tectonic regime in eastern North America. Unlike the Pacific Ring of Fire, the Appalachian area is located in the center of a tectonic plate, away from subduction zones. However, this does not imply it is immune to internal reorganization. New models of intraplate deformation show that even inactive zones might undergo gradual but significant transformations caused by mantle convection, flexural stress, or old structural defects. If the Appalachian Uplift evolves into a full-fledged rift system, or even merely accelerates, it will rewrite geological maps, change risk profiles, and call into question everything we thought we knew about continental interiors. This is not only a regional event, it might be the opening note of a new geodynamic symphony unfolding beneath our feet, and no one knows how long it will continue. The Appalachian Mountains are rising, and this narrative is far from done. Each satellite scan and seismic report reveals another piece of this geological jigsaw. Is this an uncommon occurrence, or the beginning of a tectonic change that might permanently alter the eastern United States? We'll be tracking every twist, turn, and tremor. So if you want to remain ahead of the news, make sure you subscribe immediately. Tap the bell symbol for real-time updates, and don't forget to leave a comment. What are your thoughts on the unexpected increase? Is nature issuing a silent warning? Join the conversation because the Earth is moving, and the next chapter might transform all we thought we understood.